For centuries, the world of atoms and the particles within them remained shrouded in mystery. Scientists knew that atoms existed, but their inner workings were a puzzle waiting to be solved. How could we possibly observe something so incredibly small, something that existed beyond the reach of even the most powerful microscopes? The answer lay in the realm of ingenuity and groundbreaking experimentation. In a pivotal moment that would forever change our understanding of the universe, scientists achieved the unimaginable. They witnessed subatomic particles for the very first time. This groundbreaking discovery opened up a new realm of scientific exploration, revealing the fundamental building blocks of matter and paving the way for countless technological advancements. The quest to understand the nature of matter is a tale as old as science itself, a journey that has spanned millennia and crossed countless cultures and civilizations. From the ancient Greeks who pondered the existence of indivisible particles, known as atoms, and debated their properties and behaviors, to the alchemists who sought to transmute elements into gold and discover the elixir of life, humanity has long been captivated by the fundamental ingredients of our world, driven by a desire to understand the building blocks of everything around us. But it was not until the late 19th century, with the advent of more sophisticated scientific instruments and methodologies, that scientists began to develop the tools and techniques necessary to probe the atom and unlock its secrets. One of the pioneers in this endeavor was the brilliant British physicist Sir J.J. Thomson, whose work would forever change our understanding of the atomic world. Working at the renowned Cavendish Laboratory in Cambridge, England, Thomson was renowned for his meticulous experimental skills and his unwavering determination to push the boundaries of scientific knowledge, often working long hours to perfect his experiments. He dedicated his career to unraveling the mysteries of electricity and magnetism, fields that were still in their infancy at the time, and his groundbreaking research would ultimately lead him to one of the most profound discoveries in the history of science: the identification of the electron, a fundamental component of the atom, which opened up new realms of scientific inquiry and technological advancement. Visualizing subatomic particles posed an immense challenge to scientists. These particles are incredibly small, far smaller than the wavelength of visible light. This meant that traditional microscopes, which rely on light to illuminate objects, were simply not powerful enough to resolve these tiny entities. Imagine trying to study the intricate details of a grain of sand from miles away. It was a task that seemed insurmountable at the time. Traditional methods of detection, such as observing the scattering of light or measuring electrical currents, provided only indirect evidence of the existence of subatomic particles. Scientists could infer their presence and some of their properties, but they couldn't directly observe these elusive entities. It was like trying to understand the behavior of a flock of birds by only hearing their chirps and seeing their shadows. To overcome these challenges, Thomson and his team turned to a device known as the cathode ray tube, a revolutionary piece of technology at the time. This ingenious invention, a precursor to the modern television and computer monitor, would prove to be instrumental in their groundbreaking discovery. It was not just a tool, but a window into the unseen world of atomic particles. The cathode ray tube consisted of a sealed glass tube from which most of the air had been evacuated, creating a near-vacuum environment essential for the experiment. Inside the tube were two electrodes, a negatively charged cathode and a positively charged anode. These electrodes were crucial for generating the mysterious rays that Thomson was so keen to study. When a high voltage was applied across the electrodes, a beam of mysterious rays, known as cathode rays, emanated from the cathode and traveled towards the anode. This beam was a subject of great curiosity and speculation. These rays were invisible to the naked eye, but they could be detected by their ability to cause certain materials to fluoresce or emit light when they struck them. This fluorescence was a key indicator of the presence and behavior of the cathode rays. Thomson realized that these cathode rays held the key to unlocking the secrets of the atom. His observations and experiments with the cathode ray tube would eventually lead to the discovery of the electron, forever changing our understanding of atomic structure. Section 5. A moment of revelation, witnessing the unseen. The key moment of discovery came when Thomson applied a magnetic field to the cathode ray tube. To his astonishment, the cathode rays were deflected by the magnetic field, and the direction of the deflection indicated that the rays were composed of negatively charged particles. This was a revolutionary finding, as it suggested that these particles were much smaller than atoms themselves. Thomson had discovered the electron. The air crackled with excitement as Thomson and his team witnessed the unmistakable deflection of the cathode rays. It was a moment of profound scientific significance, a testament to the power of human ingenuity and the relentless pursuit of knowledge. For the first time in history, humanity had peered into the heart of the atom and glimpsed the fundamental building blocks of matter. Section 6. Unlocking the secrets of the atom. The discovery of the electron sent shockwaves through the scientific community, fundamentally altering the landscape of physics and chemistry. This monumental breakthrough revolutionized our understanding of the atom, which had been a subject of intense speculation and study for centuries. Thomson's meticulous experiments provided the first conclusive evidence that atoms were not indivisible spheres, as John Dalton had proposed in his atomic theory. Dalton's model, which had dominated scientific thought for nearly a century, was now challenged by the idea that atoms were complex structures composed of even smaller particles. This groundbreaking discovery paved the way for a new era of atomic research, as scientists raced to unravel the mysteries of this newly revealed subatomic world. Thomson himself proposed a model of the atom known as the plum pudding model, in which he envisioned the negatively charged electrons embedded within a positively charged pudding. This model suggested that the atom was a sort of cosmic fruitcake, with electrons scattered like raisins within a positively charged matrix that made up the bulk of the atom's mass. While this model would later be refined by Ernest Rutherford and Niels Bohr, it represented a crucial step forward in our understanding of atomic structure. The work of these pioneering scientists laid the foundation for modern atomic theory, opening up new possibilities in science and technology. Section 7. From fundamental science to technological marvels. The discovery of subatomic particles was not merely an abstract scientific achievement, it had profound implications for technology and our everyday lives. The understanding of electrons in particular laid the foundation for the development of countless electronic devices that have become ubiquitous in the modern world. From the humble light bulb to the sophisticated smartphones in our pockets, the impact of Thomson's discovery is all around us. The development of the television, for example, relied heavily on the principles of cathode ray tubes, which were refined and adapted from Thomson's original design. Similarly, the transistors that power our computers and smartphones are based on our understanding of the behavior of electrons in semiconductors. The ability to manipulate and control these tiny particles has revolutionized communication, information processing, and countless other aspects of modern life. Section 8. A new era of scientific exploration. The discovery of subatomic particles marked the dawn of a new era of scientific exploration, particle physics. This exciting field of research delves into the fundamental constituents of matter and the forces that govern their interactions. From the discovery of the proton and neutron to the identification of exotic particles like muons and neutrinos, particle physics has continued to push the boundaries of our knowledge and reveal the hidden workings of the universe. Today, massive particle accelerators, such as the Large Hadron Collider at CERN, accelerate particles to nearly the speed of light and smash them together in spectacular collisions. These experiments generate a shower of new particles, providing scientists with invaluable insights into the nature of matter, energy, space, and time. Section 9. Inspiring future generations. The story of the discovery of subatomic particles is not just a tale of scientific triumph, it is a testament to the power of human curiosity, ingenuity, and collaboration. The pioneering work of scientists like J.J. Thomson continues to inspire generations of young minds to pursue careers in science, technology, engineering, and mathematics fields. By fostering a love of science and encouraging exploration and discovery, we can empower the next generation to tackle the grand challenges facing our world and unlock even greater mysteries of the universe. Section 10. The unending pursuit of knowledge. The quest to understand the universe is a never-ending journey. As we delve deeper into the subatomic world, we continue to uncover new particles, new forces, and new mysteries that challenge our understanding of the cosmos. The discovery of the Higgs boson in 2012, for example, provided crucial evidence for the mechanism by which particles acquire mass. Yet, despite all that we have learned, countless questions remain unanswered. What is dark matter, which makes up the vast majority of the mass in the universe? What is dark energy, the mysterious force driving the accelerated expansion of the cosmos? The pursuit of these and other fundamental questions continues to drive scientific inquiry and fuel our insatiable thirst for knowledge. Section 11. Join the journey of discovery. The discovery of subatomic particles was a pivotal moment in the history of science, marking a profound shift in our understanding of the universe and paving the way for countless technological advancements. As we continue to explore the subatomic world, we can only marvel at the wonders that await us and the boundless potential of human ingenuity. So let us embrace the spirit of discovery, engage with the wonders of science, and embark together on the never-ending journey of unraveling the mysteries of the cosmos. Share your thoughts, ask questions, and stay curious. As we reflect on the monumental discoveries in the realm of subatomic particles, it's essential to recognize the ripple effect these breakthroughs have had on our world. From revolutionizing medical imaging techniques to advancing quantum computing, the impact of understanding the building blocks of matter extends far beyond the laboratory. These advancements not only enhance our quality of life, but also open new frontiers for innovation and exploration. Imagine the countless possibilities that lie ahead as we continue to delve deeper into the subatomic world. The quest for knowledge is a journey without end, constantly pushing the boundaries of what we know and what we can achieve. It's a testament to human curiosity and resilience, and each discovery brings us one step closer to unlocking the ultimate secrets of the universe. So, as we conclude this chapter, let's remain inspired by the spirit of scientific inquiry. Let's continue to ask questions, seek answers, and marvel at the universe's wonders. The journey of discovery is a collective endeavor, and your curiosity fuels the next wave of exploration. Thank you for joining me on this incredible journey. Remember to like, subscribe, and hit that notification bell to stay updated on all things science. Until next time, keep exploring the wonders of the universe.